Hi Year 9, welcome to the first video in our unit on trigonometry. In our last unit we studied Pythagoras, which looked at the relationship between the lengths of the sides of a right angle triangle. In trigonometry we take this one step further and we look at the relationship between the sides and the angles in a triangle. The first thing we're going to need to do is go over a bit of terminology that you need for this unit. So the first thing we have to do is we have to be able to label our sides of the triangle. And the sides are labeled with respect to a marked angle, not the right angle, but one of the other two angles in the triangle. Now often we use the Greek symbol theta to represent the angle, so that's just a circle there with a line drawn through it. Okay. We've got three sides here and we have to give them three different labels. The first one you should already know from our unit on Pythagoras, and that is the hypotenuse. So if you remember, the hypotenuse is the longest side and it's the side that is directly across from the right angle. So this side here would be our hypotenuse. Okay, and that's side AB. The next side we can look at is we take a look at the angle that's been marked, so this angle here, angle B or theta, and we look at the side that is opposite that. So that would be this side over here, side AC, and that's called the opposite side because it is opposite the angle that's marked. Okay, and the last side is going to be the side that is just touching the angle that's marked, and it's in between the right angle and the marked angle. So that's this side here, and that's called the adjacent side. Okay, so we've got our three labels here: the opposite side, the hypotenuse, and the adjacent side. Now, one thing we have to realize is that these sides are always labeled with respect to the marked angle. So if the angle changes, so do the labels of the sides. So for example, if we had marked this angle, so angle A was our theta, then we still have the hypotenuse, that doesn't change. Okay, because that's always the longest side. But now the side that is opposite our marked angle is this one over here. So this is now the opposite side. Okay, and this one would be our adjacent. Okay, so that's the first step that you're going to go through when you're doing any of these trig problems, is just labeling your sides. Okay, the next thing we need to know are the three trigonometric ratios. The ratios compare the lengths of the sides of the triangle. So again, the first thing we're going to have to do is we're going to have to label our hypotenuse, our opposite, and our adjacent side. So we've got our hypotenuse here, we've got our opposite side here, and we've got our adjacent side here. Now the three trig ratios, which you might have heard before, are sine, cosine, and tangent. So these are the three that we're going to be looking at this year. Okay, and the relationship for sine is the sine of any angle, theta, is equal to the length of the opposite side over the hypotenuse. Okay, so the sine is equal to the opposite over the hypotenuse. For cosine, the relationship is the cosine of any angle, and we just sort of write cos theta, is equal to the adjacent side over the hypotenuse. And for tangent, we would write the tan of any angle is equal to the opposite over the adjacent. And we're going to look at what that means with numbers in a second. But for now, you need to know these three ratios. And you might be thinking, how am I going to remember this? But there's a really clever way. Well, I don't know if it's clever, but a really good way that people remember this is using the word SOHCAHTOA. So this is our word here, SOHCAHTOA. Okay, and what this is saying is that this is our sine ratio. Sine is the opposite over the hypotenuse. Cos is the adjacent over the hypotenuse. And this one, tan, is the opposite over the adjacent. So SOHCAHTOA is a really good way to remember your three trig ratios. And you might come up with a better way to remember them. Obviously, you can share that with the class or comment on the video if you've got a better way to remember those ratios. Okay, the last thing we're going to do in this section is we're just going to start to write trigonometric ratios, and we're just going to leave them in fraction form to keep it simple. Okay, so let's take a look at how we're going to do this. Now, when you start any trig questions, it's often helpful to just write SOHCAHTOA at the top so you can refer to it at any time. So let's just write that here. Okay. Now, this purple triangle, we've got a marked angle theta in the bottom left corner here, and we've got two sides that are labeled. So first of all, we want to figure out which sides those are. So clearly 7 here is the hypotenuse because it's our longest side, and 5 is the adjacent side because it's right beside the marked angle and between the marked angle and the right angle. So we'll mark that with an A, that's our adjacent side. Now, looking at your trig ratios, you want to see which one has the adjacent and the hypotenuse in it. So if you look here, cosine has adjacent and hypotenuse. So the cosine is the ratio that we're going to use in this case. So we know that the cos of any angle theta is equal to the adjacent over the hypotenuse. But we know the adjacent is 5 and the hypotenuse is 7, so we're just going to substitute those numbers in. So our trig ratio would be the cos of theta is equal to 5, because the adjacent side is 5, over 7. And that's it. We're going to leave it as a fraction. That's our trig ratio done. Let's look at another example here. We'll look at this yellow triangle. Okay, so we've got a marked angle, theta, and let's work out which sides we have. So in this case, 9. This length here is 9, and that's our hypotenuse. And the length of this side here is 4, and it's opposite our marked angle. So that's the opposite side. So we've got the opposite and the hypotenuse in this case. So look at your trig ratios and find the one that has opposite and hypotenuse in it. And hopefully you can see in this case, I'll circle it this time, in this case we're going to use sine, because sine is the opposite over the hypotenuse. So let's write our trig ratio. Sine of theta is equal to the opposite over the hypotenuse. Okay, and substitute the values that we know. So sine of theta is equal to the opposite, which is 4, over the hypotenuse, which is 9. Okay, and that's it. So there's one last one here. You can give it a go on your own first if you'd like, so you can pause the video and try it. Otherwise, you can follow along with the answer here if you're still unsure. Okay, first step, again, label our sides. So our marked angle is down here. So that 2 there is the opposite side. And the 3 is our adjacent side. So in this case, we're not using the hypotenuse. It's not labeled for us. Okay, so you can probably see the only other one we haven't used yet in this example is the tangent ratio. And the tangent is the opposite over the adjacent. So let's just write that down here. So we've got our ratio, the tan of theta is equal to the opposite side over the adjacent. So if we substitute our values in, the opposite we said was 2, and the adjacent is 3. So the tan of theta is 2 over 3, or 2/3. Okay, so now you should be ready to write your summary and your question to finish off your homework for tonight, and we'll look at some classwork tomorrow in class. All right, thanks for listening, guys. Bye-bye.